So today we will start introduction to offshore structures with offshore platforms, the types of offshore platforms. Now there are various categories of offshore platforms, so it is better to subdivide them according to their functions. So we will come across the design aspects later on, but first you know what are their basic functions. Now you divide offshore platforms into two broad categories. The first one you call fixed. Actually, your dynamics of the platform is distinctly distinct for these two categories. So first one will be called fixed and the other one is mobile. Now under these headings of fixed and mobile, you again subdivide. So under the fixed categories, you have compliant and rigid. Fixed is basically they have their base is connected with the seabed. We will discuss about the compliant category. Compliant means the structure complies with the external load. So the other one does not comply, it is called rigid. And again under the mobile category, that means these types of structures, they do not have any connection with the seabed, excepting of course jackups to some extent. In the drilling mode, they have their foundation on the seabed, but most of them are floating. So these are the first category is submersibles. Then you have jackups. Now these submersibles are different from what is those ROVs. So these are the other category is jackups. Then you have semi-submersibles. Nowadays actually the first category you have not many. So semi-submersibles are more dominant. The last category is drill ships. Now under the compliant head, you have the major categories, but we will discuss all this in detail later on. And most of them are used actually for mooring buoys. So first one is your guide tower. Then it is articulated mooring. The last category you have TLP, or simply you write tension leg. Another rigid category, that means platforms not having any motion. So here you have two types. First one is concrete gravity. And the last category you have piled jackets. So these are the various types of offshore platforms you come across. Now actually these structures have evolved over the last say 50 years or so. There have been rapid development in the offshore oil business. So with that, the structures have gone from shallow waters to deep water. Now here actually you will find, to start with, let us start with the fixed category. The more problematic varieties are with the these categories, your jackups and the compliant category. So here you have, start with the jackups, jacket platforms. Now here I think you can see this. Here is a picture of a jacket platform. This, of course, I have taken a slide. Now here you can see the various components. That is, this is your derrick, and the heli deck is here, and this is your the deck house, and this is supported on a truss. This is a three-dimensional truss, and here you can see that there are a number of conductor pipes, that is the marine risers, which take your oil from the seabed to the platform top. Now one of the major advantages of this structure is that you have the BOP essentially at the deck. You can service the blowout preventer from the main deck, and you can see the piles. Now here actually you have to drive the piles through these sleeves. You can see the hollow rings at the periphery of the column. So these are the larger columns. You can see one column here, 2, 3, and this is slanted column. So this column is actually widening the base. Now here, so these are risers, and you can see another pump. The risers actually are taking out oil from the wellhead or from the oil well down below, and they are export. So AIM is called a export pipeline. That means the oil is carried through this pipeline onto a tanker. So there will be some small oil well out here where it is fed to a tanker. Now when you drive a pile, so these sleeves are there to drive the piles. The piles are driven through these sleeves, through these guides. You can see the guides, and onto the seabed down below. So this is a pile guide, and this is a truss type of structure. You can see the bracings. Normally the bracings you will find there are X or K bracings. So you do not have bracings in a random way like this. In a jacket platform, you go either for X type of bracings or K bracings. Now these bracings have been designed after a lot of thought, such that there is no failure at the joints. So here you can see, now what has not been shown out here is at the base you will find a mud mat. Sometimes at the base you will find this is a rectangular type of flat base, and here you have a steel plate at the corners. Now, this has been given for the reason of, so this is called a mud mat. Your conductor pipes actually will go somewhere here down below to the well. So, conductor pipes will be here, this is your mud mat, and these are your the horizontal bracings of the platform. So, mud mat is given to give bearing support to platform. The platform will be having tremendous weight. So, this jacket platform will be of the weight, I do not know, this water depth has not been given, say around say 100 meters. So, you can imagine the jacket, normally the Mazagon Dock jacket that has been built for Bombay High, weight is somewhere of the order of 1350 tons. Now, all this weight has to be supported on the seabed, you know. So, what you have to do is, first you have to build the truss, and literally you have to pin this down to the seabed by means of piles. Now, as I see here, I think this jacket does not have the long piles which are driven through the columns. Now, sometimes they also drive piles through these columns. So, those are called the main piles, and the other you can find around the circumference, there are the shorter piles, these are called skirt piles, and here you can see there are as many as 8 around, I think here it is less, around each of the main columns. So, these piles actually, the function is, so this is jacket, is basically jacket platform has pile foundation. In civil engineering, actually they are more comfortable with this term, that is they call pile foundation, or sometimes these pile foundations, they are also called deep foundations. A pile foundation is another term for a deep foundation. Why? Because the piles are literally driven, say 20-30 meters into the seabed. So, that is why it is called a deep foundation. Now, here the major environmental force that is coming to this platform is horizontal wave load. Horizontal wave load. So, this is your major force. Now, this causes, there are two types. So, major external load, right. So, as I have said, this will cause structure displacement. Now, sometimes this is called slide. There is rigid body, the structure is going to be bodily shifted along the direction of the wave. And the other is, so the slide, this is rigid body displacement. And the other is the more important one, that is called the overturning moment. Now, you have to build a structure, that is your pile foundation has to resist these two types of loads, basically horizontal load and overturning moment. So, what about the weight of the structure? So, these are the two types of loads which is coming from the environment. Now, in the structure that you see, there will be major weight coming from the deck. So, all these deck modules will be of the other weights, say 1350 ton jacket will weigh something of 1000 tons. Now, 1000 tons weight has to be supported on the seabed, isn't it? So, that is done primarily through these piles. Piles are giving you the end supports, that is the corner supports to this huge weight, and also some of the weight will be supported by the mud mat. So, the other is vertical load. Vertical load supported by piles, mud mat. Now, so these are some of the loads. The other loads that you will face is your drilling load. Now, these are called live loads. Drilling is an important function of the platform. So, these are the 4 types of loads that we will come across in a jacket platform. Now, coming to the main purpose of a jacket is to, now your jacket does not have any provision for oil storage. You can see the structure, the jacket platform does not have provision for oil storage. So, that is why you have to have an export pipeline, does not have provision for oil storage. So, that means you have to take the oil to a storage facility. So, oil transported to shore storage facility. Or tanker. So, the jacket has to be positioned in such a way such that a nearby tanker can berth. You have to have sufficient water depth, or you have this export pipeline, you can lead them to the shore facility. So, wherever you find all these jacket platforms, you will find the seabed to be literally crisscrossed with pipelines. So, pipeline is another important aspects of your any platform. Now, here actually the jackets actually have to be built. Now, jackets, whenever you build an offshore structure, you think about the economic life of the field. Economic life of oil well. Now, it is no point wasting too much of money where you have what is called a marginal field. That is, sufficient oil reserve is not there, but only small amount of oil reserve. Now, in that way, in that case actually the design of the jacket platform you have to change. Now, here the figure that I have given you, your jacket basically is of this type, that is, you have the larger columns slanted way, these are the vertical columns, and here you have the bracings. So, either you have the X bracings or the K bracings. So, this is your jacket. Now, marginal field, sometimes they do not go for all these large structures, they have a smaller platform. So, you can have smaller platforms like this. So, this is conventional, and this is marginal field. So, this is one of the primary considerations for jacket design. So, you center your platform design according to the quantity of oil within the reserve and what. So, this is one of the quantity of oil in reserve or write in reservoir to be more appropriate, and daily production rate. This is also a deciding factor on the size of the jacket, that is your daily production rate in terms of barrels per day or BPDs. Why? Because the higher the rate, that means your marine riser or conductor pipe is going to be of a larger diameter. So, the supporting facility will also have to be more robust to take account of these marine risers. So, marine risers jacket also provides support to marine risers. Jacket, now this is one of the biggest advantage, or provides efficient support, or rather you write efficient fixed support to marine riser. So, later when I talk about the drilling, I will show what is the marine riser. Now, you can go on increasing the size of these pipes, along with you increase the size, weight of the pipe. What else you will find is that the marine riser is also encountering larger wave loads. Excuse me. As soon as you increase the diameter of this pipe, so the wave load is also going to increase, isn't it? So, these pipes you can see, they are literally suspended from the deck, and in between you can give some support from your bracings at these points. So, these things this is actually a structural engineering problem. So, here this is your wave is something coming here, and the depth of the structure will be say of the order of say 90 meters. So, Bombay High is 90 meters, or I think not 90, maybe 70 meters water depth. Anyway, so this you have to give support. So, provides efficient fixed support to marine riser. This is very important. So, you have more number of supports, actually you can have what? That means it will resist the bending moment on the pipe. The bending, because of the wave load, you will find there is a large bending moment coming onto these pipes. If you give supports, some number of support points or more, so that means failure of the pipeline due to bending will be less. So, that is one method. So, you can do your finite element calculations with a beam supported at this point, and your support points. Wave load is coming in the horizontal direction. So, this I told you is an important study. These are called riser mechanics. So, you have to decide on the thickness of the riser pipeline from your daily production rate and the number of supports that you can give to the pipeline. If you give more supports, then you can go for reduced thickness, wall thickness of the pipeline, because the displacement of the pipeline or the mode shape in the vibration is going to be less. Otherwise, you have to go for thicker pipelines. So, this is one aspect that is to be considered. The other aspect is when you go for this jacket platform, you have to, it is based on the I told you that BPD is coming from the production rate. Now, this production rate, that is barrels per day, that is what I told you, is a deciding factor on your production equipment. What is your production equipment? Now, you find that is from your the marine riser, from the conductor pipes, when you take out oil. So, when you lift oil from the reservoir, oil normally comes with the associated gas, but I don't, there must be a flare stack. You can see, yeah, this G is your gas flare stack. So, the length of this stack you have to decide on the radiation of heat from the flame to the platform. It should not cause unmanageable heat on the deck of the platform. So, gas, normally the oil comes with the associated gas, and also you have some foreign materials, that is stones and all that will also come out. So, those have to be segregated. So, you have oil and gas separation facilities on deck. So, this is one of the major equipments of a offshore platform. So, that is your, or a production, that is oil and gas separation facility on deck. Now, then you have your, this is number 1, then you can have number 2. From the diagram that you can see, we have a very large deck house for crew and personnel. So, they have to be housed in a on the deck, and the other you have, so production equipment, then you have processing facilities for oil. Now, if you go to Bombay High, you will find there are two in jackets. Actually, the platform, there are two types, jackets. One will be for drilling, they are solely meant for drilling, and the other is for production. So, if you go and visit an oil field, you will find these production platforms. So, they are not doing any drilling operation, they are just lifting the oil, processing it on deck and transporting it to the tankers. So, they are called processing platforms, oil processing platforms. Now, what has happened over the years is that from the discovery of oil in a particular reservoir to the commissioning of the jacket is a long gestation period. to oil recovery. This is a long gestation period. Now, how to cut this down? Now, this almost takes as many as 12 years. So, people are not ready to wait for such a long time, for 12 years for the oil to come out of the reservoir and then market it. So, nowadays the technology has been developed for concurrent drilling and production. So, that means you do drilling as well as production at the same time. Now, if you want to go for this, that means this calls for larger deck area. And slanting conductor pipes. So, nowadays the drilling technology has also developed over the years, and this type of drilling is called deviational drilling. Now, here in this you can drill as many as, the number is I think 12 or 13. So, 30 wells. Deviation drilling, you can drill up to 30 wells. So, drilling can be done in up to 30 wells, and you can service as much as within 4 square kilometers of seabed area. So, that means here you have the jacket platform and you are drilling. So, that means your drill string or drill pipe is not vertical. You can do, I am just giving an exaggerated view. So, this is one drill pipe going in this slanted way. So, through this you have your drill string, that is this is your drilling riser, like this it is going, and at the end you have the drill bit. So, this is called deviational drilling or slanted drilling. So, that means this deviational drilling, it is done at an angle with the vertical, and there are wedges at the seabed to keep this in place. So, here you have one drill string, you can have one other drill string which is vertical. So, like this you can service 4 square kilometers of seabed area, and you can drill as many as 30 wells. So, this is one aspect of drilling technology which has developed in order to drill more oil wells from a single platform. So, this is done in this fashion. Now, this is here. Now, this requires expertise, and so whenever you are building this kind of platform is always designed to take care of nature of drilling. Nature of drilling and more important is how many wells you can drill and service. Wells to be drilled and serviced. So, this is another deciding factor. So, all these production facilities, the deck actually you build this structure which you can see here, that is there are two major components of this jacket platform. What are the major components? Or two major structural configurations. One is your this underwater truss. There is this truss you can see is massive. So, 90 meters, say this will be around say 13 or 14 meters by 10 meters, is a small jacket. The other is the deck module. So, these are the two distinct structural configurations which are fabricated separately. So, that means truss and deck fabricated separately. You do not build the truss along with the deck. And then joined in the sea, joined at sea. So, two major structural configurations are the truss and the deck. Now, truss also you cannot build at one go. The truss that you see in this figure, it is built in the shipyard. Truss built in shipyard. Now, how are you going to build this truss? So, you have to have certain knowledge of shipbuilding production, isn't it? Now, ships are actually normally built in what? I don't know whether you have done shipyard organization, shipbuilding. Ships are normally built in segments. Have you come across it? Have you been? Ships built in segments. Now, these segments, they are called weldments. That is, say this is the hull of the ship. You do not build the hull at one go, or for large, say large vessels in the hull shop, they divide the hull into parts. So, like this, and then you build, say the forepeak is built separately. Say this is one hold, a hold assembly is done like this. So, these are the various blocks that are built. So, basically this is called a block assembly or block assembly. So, these weldments, say the forward portion, you can build it upside down, say like this, say because it is easier that way, isn't it? And then you put it right by means of cranes and join these sections or weld these sections. Now, this sort of thing is done in the hull shop. If you go into the shipyard, you will see. But in case of these jacket type of platforms, now jackets, you can see that this is a truss. So, here you do not build the jackets in your jackets are normally built not in a, now ships you will find they are built on ships are built where? Ships are built in a slipway. You should be conversant with all these terms, but jackets built on horizontal dock. The slipway, you will find that it has a certain declivity or inclination. Jackets you do not build on this kind of declination, you build on a horizontal dock as flat panels. So, jackets you can see these are composed of large number of pipes which are welded together onto them. These are the major columns and here you have the bracing members. So, you build them on flat, laying flat on the dock. Say these are the columns and these are your bracing members. So, these are, you build them on flat on the dock. So, because it is easier this way to fabricate, and then you rotate it by means of cranes. You lift this up. So, this gets in the vertical mode, you bring another panel by means of cranes and join the bracing members, weld the bracing members together. So, that is how your jackets are built. So, when you go for training at the end of third year, you happen to visit any of these offshore companies, you can see this fabrication being done. Anyway. So, this is one aspect which has to be covered. Now, here lot of stresses are developed at the erection stage. Stresses are developed during erection, or rather you write during fabrication. This is just one example. Now, if you are not careful, you will find that this panel you have not been able to bring closer together, sufficiently close for this bracing member to be welded, or sometimes what is done, you force fit. So, this is a very precision kind of task. You try to force fit one panel with another panel. Normally, if you are not careful, then I will do it. So, what will happen? There are a lot of stresses will develop at the junction between the columns and the bracing members, and when you release them, when the jacket is released or when it is being transported to the launch barge, you will find cracks are developing. These are the favorable spots for what is called stress concentrations. So, jacket is normally a very huge structure, and if you are not very careful during the fabrication stage, this leads to stress concentrations developing at the joint. Now, there is a particular name given to this aspect of shipbuilding. In ships also you will find you have not made this panel perfectly matching with this panel, then you have a lot of welding stresses coming up in this region. and then you will find cracks being developing. So, this aspect in shipbuilding is called workmanship, or sometimes this is a result of what is called poor workmanship. So, it is a very important part in shipbuilding. So, this actually the workmanship tells you a lot about quality of weld also. Anyway, so this is what is coming up right here. So, the problem with the jackets is in shipbuilding or these platforms, you always go for ease of fabrication. Ease of fabrication and also erection. How much easily you can do it without lot of stresses and strain coming onto the platform, because these are essentially very large structures, because jackets are large structures. The ships are also large structures, so they have inherent tendency to become to have all these unfriendly hot spot stresses coming up. So, this has to be taken care of. Now, you build a truss. Truss is essentially built to withstand wave loads. The major load is your wave load. Increase in water depth. Now, if you increase water depth, what will happen to this truss? So, if you want to build this truss, so the truss is built to take care of the horizontal wave load. There are other loads which are coming on, is your current and also your wind load. So, increase in water depth leads to increase or decrease. What will happen if you increase water depth? Increase in truss size. Why? What has depth got to do with truss size? Suppose you increase the depth of the sea, then why the truss size has to increase? Because you have to lift the deck above the water, and this is a certain height above the water, they call it air gap. So, you have to maintain this constant depth. Now, if you increase the depth vertically, you have also to increase the base width. The reason is you have to counter the overturning moment. So, once you increase the depth, that means the moment arm is increasing. So, with increase in depth, the moment arm increases. Moment arm increases. With consequent increase in base width. So, in your offshore engineering, so this is you have to play around with the environmental load and moment. Moment is also a very important factor. Moment term increases with consequent increase in base width. So, that means to prevent this structure from toppling. Now, so far so good, but what will happen to the size of the bracing members? So, that means, so first is you have with increase in depth, you have also increase in width. So, that means all these length of the bracing members has increased. Followed. Now, the structure has also increased in size, both length, that is depth wise and breadth wise. So, now you cannot have the same thickness of bracing members, because the greater amount of load is going to come. So, bracing member size, and so you write bracing member thicknesses also will be increased. So, now you are encountered with another twin problem. So, the structure you have increased in size, and you have increased all the thicknesses and column diameters, and you have also increased by that manner the wave load that is coming on the structure. So, as a consequence of that, you have to increase also the pile diameter and length. So, with increase in size of the structure, all your parameters which define the geometry of the truss has increased by simply increasing the water depth. So, whenever for fixed structures, water depth is a very important category in determining structure size. So, you find that water depth is a prime deciding factor or a governing factor for determining structure size. So, here you will find structure tends to be uneconomic. So, the owner of the platform is not going to pay you if you indiscreetly increase the structure size. So, that means your jacket platform is going to become unviable after certain depth. So, this is an example I have given where the water depth is a overriding consideration. So, becomes unviable at large depths or at a large depths of water. So, this is one reason. So, this is the main drawback of a jacket platform. The other parameter which defines the size of the jacket is this. Deck area. Deck area is another important parameter for structure size, because what essentially you are doing is the truss that you have built is it is giving a support to the deck. So, you increase the deck area, obviously you cannot have a very narrow jacket, your deck will start bending like this. So, that means you have to increase the structure breadth wise or width wise. So, that will come because now this is dependent on primarily dependent on oil and gas production facilities that you are going to house. So, this brings us to the end of this lecture. Now, next lecture I will continue with this and go to the gravity platforms.